or 3D, we start looking at points of inflection. So here we specifically look at the change in shape from a concave curve into a convex or vice versa. So we are identifying points of inflection as either stationary points of inflection, where they would go from a section of a concave into a section of a convex with a stationary point, or a non-stationary point of inflection, which is where our two sections just meet and the slope is not equal to 0. So to do that, we need to firstly find the first derivative. So this is a similar, well, it is the same function as we used previously. 4x cubed take 24x squared, and we found that the first derivative has a common factor of x take 6. So our first derivative has stationary points at x equals 0 and x equals 6. And we would go ahead and we would show a sign diagram of the first derivative with 0 and 6. Now we've done this before, so I think it was this example here of 1.20. We found the sign diagram was negative, negative, positive. So negative, negative, positive. That tells us we've got a point of inflection here because of the two negatives, but we can confirm that using the second derivative. So the second derivative of this function, we can use the unfactorized form because it would be a lot easier. No need to use the product rule. We would get 12x squared take 48x, and in this case factorizing, we would get 12x x take 4. So our second derivative, sign diagram, is going to have 2 points, one at x equals 0 and the other at x equals 4. And you can see I've tried to do those above each other so that these match and align with each other. So the 0 being a stationary point but also a point of inflection tells us it's going to be a stationary point of inflection similar to this top curve. So we still need to produce a sign diagram for that. The second derivative, if we were to put a negative number into here, we would get a negative times by a negative becoming a positive. If we had a number like 1 in there, we would get a negative times by a positive, causing us to get a negative, and a number like 10 being a positive times a positive, so a positive result. Now, because the signs change, we do have a series of 2 points of inflection, one at x equals 0, one at x equals 4. The stationary point aligning with our point of inflection results in a stationary point of inflection. The value of x equals 4 not aligning with a stationary point means that it is a non-stationary point of inflection, and we can identify that in our graph. So this point of 0 indicates a stationary point of inflection, and if we change our view window, it was negative 420, so we'll put negative 450. Way around. Negative 450 and 50. We're going to have another non-stationary point of inflection here at 4. We can find the y coordinate of that using the trace function. So y is equal to negative 244. So we come back to here, our stationary point of inflection is at 0, 12. And our non-stationary point of inflection is at 4, negative 244. So points of inflection identify the change of shape, and we do that by using the second derivative of our function.